Hi there, you're all welcome to Nkwain Sam Music. Today I want us to talk about fundamental frequency. I have been avoiding this topic as a mixing engineer, as a mixing student, and it has really been affecting my mixing. Frequency is something you must have an idea about if it comes to mixing, because this is sound. We're talking about sound, and many of us who were shying away from physics, we've encountered sound and waves, again when it comes to music production. Why am I bringing this topic? A lot of times we are just doing mixing because we followed a preset. Maybe they said put your EQ, cut from here, you compress. But then the real thing you need to ask yourself is, why am I inserting this plugin? Why am I putting the EQ? And if I'm putting the equalizer, where am I supposed to cut? Where am I supposed to boost? And why? That is where fundamental frequency comes in, and it's very, very important. Here's a frequency spectrum. We have the amplitude on the left, that's the vertical axis, and we have the frequency on the right. So I'm now talking a bit of physics, and like I say, if you want to really be a mixing expert, then you need to have a little bit at least of knowledge about sounds, movements, waves, frequency, amplitude, and lots more. So that said, we have here, like I mentioned, we have a frequency spectrum. And then the blue lines, which are representing waves, their particular positions in the frequency. So let's not forget, our topic is fundamental frequency. I'm just trying to give us this introduction so that we should figure out what a fundamental frequency is all about. So what is a fundamental frequency? A fundamental frequency is the lowest sounding note on the frequency spectrum with the highest amplitude. Let me repeat. The fundamental frequency is the lowest sounding note with the highest amplitude on the frequency spectrum. If you look at the board right here, you will see that the lowest sounding note here is on 220 hertz. So that's the fundamental frequency. And this particular frequency gives the sound its timbre, what they call timbre, meaning that if you use a particular instrument, for instance, let's come here, let's say piano, the amplitude here is 261, will give you the sound of a piano. When you go to the violin, it has the same position on the frequency spectrum, 261 hertz. But then the volume, that's the amplitude, is not as loud as that of the piano. Look at it keenly. I'm hovering there. That is what gives you the sound of a violin, the timbre, the character, so to say. The tonal center. Same applies to the trumpet and the flute. Their lowest frequency with the highest amplitude is what gives them the particular character. So much so that it makes you to realize that this is a flute and this is a trumpet. Now, this will make you to understand as well that a piano and a violin, they have the same frequency, even though their amplitudes are different. And that will enable you to know how to pan, because if you put these instruments, or say these events, on the same spectrum, which is okay, without panning them, you are going to have them clashing, and I'm not sure that's what we want. So you have to pan them left and right so that you can make space for each and every instrument. And not just that, it helps you to realize that the piano might be a legato formula, while the violin may be a staccato formula, or the trumpet may have a different flow, so that they do not clash. That's the second advantage of knowing where the frequency spectrum of any particular instrument is found. I also invite you to Google and find out the fundamental frequency of each instrument. I also want to indicate that there are certain instruments that do not really have fundamental frequencies, especially instruments that are non-tonal. A shaker, for example, a cymbal, all of these do not have fundamental frequencies. So you may just look at them and then you know how to EQ. Like I said, the major reason why we are studying fundamental frequency is to know how and where to EQ. In other words, I don't expect you after this lesson to go again and begin to cut fundamental frequency, because that is the most important frequency on the frequency spectrum. You need to leave it as it is. You may cut the other frequencies, which are most probably harmonics. And harmonics are a multiplication of the fundamental frequency. And the higher the frequency, the lower the harmonics. So even while cutting the harmonics, you need to be very, very careful. Now, depending on the other instruments, it's up to you to know when you can cut or boost a particular harmonics. Like I said, these are all harmonics. The real timbre, the real character of the instrument is found in the fundamental frequency. So in the next lesson, which is still a mixing lesson, based on the fact that we have discussed on fundamental frequencies, I will now be using examples on my digital audio workstation. You are going to learn how fundamental frequencies influence, the panning of instruments. I'm going to demonstrate, so to say. We are going to do a case study of one of my productions so that you can actually understand how to discover that fundamental frequency on your frequency spectrum and how or where to cut and how to pan so that you make space, because the essential is for every instrument to be heard during the final mix. So I hope I helped you in one way or the other. So if there's any other thing you would like to learn, or any question, you can always leave a comment in the comment section and I'll be happy to respond. Additionally, if you have some input, of course, why not? You can put it in the comment section and we are going to learn together. Don't forget to like and subscribe to our channel, and if this video is making sense to you, why not? Just leave us a like. Thank you and have a nice time.